the line segment QT is equal to root 8 units, with points Q, 4, 1, and point T with coordinates 2y. Find the value of y. Now we need to find the y coordinate of a point, but we use the formula in exactly the same way as our previous example. The equation gives us the length of QT in surd form as root 8. So we can make a note of this over here. We can say square root of 8. Now let's fill in the rest of the formula. Let's say that Q is our first point and T is our second. So we say square root 8 is equal to y minus 1, close the bracket, squared, plus 2 minus 4, close the bracket, squared, all under a square root. Now in this case, we need to solve for y. So the first thing we have to do is to square both sides of the equal sign. We want to get rid of the square root. On the left, the root and the square will cancel out, and we're left with 8 is equal to, on the right, the root and the square will cancel, and we're left with the brackets y minus 1 squared plus our second bracket 2 minus 4, which gives us negative 2. So we say negative 2 squared. Now we can square our brackets. On the left, we have 8 is equal to y minus 1 squared. We get y squared minus 2y plus 1. Then we have plus negative 2 squared, which is positive 4. Let's tidy up the right-hand side. So we have 8 is equal to y squared minus 2y. 1 plus 4 gives us positive 5. Now we may be working with a variable y, but we have a y term and a y squared term. So we are still working with a quadratic that we need to factorize. Let's make this equation equal to 0. Our squared term is positive, so we can say y squared minus 2y. Then we're going to move 8 to the right-hand side, which becomes negative 8, and 5 minus 8 gives us negative 3. And we can now make this equation equal to 0. Now we can factorize this into two brackets. 3 only has two factors, 1 and 3. 3 is negative, this 3 over here, so one factor will be negative. The coefficient of the y term is negative 2, which means the larger factor will be negative. So our factors are 1 and negative 3. And now we can fill in our brackets. We can say y plus 1 and y minus 3 is equal to 0. From this, we can now see that y could be equal to negative 1, or y could be equal to 3. But again, we only have one point. It can only have one y coordinate. We know that from our work on the Cartesian plane, y is positive above the origin and negative below it. Point T lies below the origin, so y must be negative. From this, we can see that y cannot be positive 3, which means y must be equal to negative 1. Let's look at another example.